Hi everyone. Today what I want to discuss is how to solve equations with variables on both sides of the equal sign. What we're going to end up doing to solve equations with variables on both sides of the equal sign is we're going to have to move variables in an equation like this. If I have 3x plus 7 equals 2x plus 5, the barrier to solving this is the fact that we have a 3x and a 2x on opposite sides of the equal sign. We can't combine them because the equal sign is our barrier, so we need to find another way to go about this. Where I'd like to start is by looking at fact families. Fact families are three numbers that are related through some type of operation. My original fact in this first one is 9 minus 5 equals 4. And I believe everyone could agree that 9 minus 5 does equal 4. We can rewrite this fact by performing an operation to one side of this and moving the 9 to the other side of the equal sign. So let's try it. 9 is positive, and if I have negative 5 equals 4 and 9, the only way that I'm going to get negative 5 is if I take 4 minus 9. So that means that I would subtract 9 and subtract 9 on both sides. Remember how 9 and negative 9, they're opposites and opposite operations, so they'll cancel. So we get negative 5 equals 4 minus 9. Let's try another one. 7 plus 2 equals 9. Let's keep the 2 this time and move the 7 to the other side. If we keep the 2, that means that we have 9 and 7. What operation can we do with 9 and 7 to get 2? Hopefully you guys are thinking that it would be 9 minus 7. Algebraically, what we're doing is we're going to subtract 7 from both sides of the equal sign. When we do that, we get 2 equals 9 minus 7, and most of you guys out there are saying, yes, 2 does equal 9 minus 7. These are two different values from the same fact family. Here's another problem. We have 12 plus 5 equals 17. I'd like to keep the 5. So that means we have to move the 12 to the other side to make a new member of the fact family. So to do that, if I have 17 and 12, that would be 17 minus 12 gives us 5. So we're going to subtract 12 on both sides of the equal sign. Notice what's happening is we're doing the opposite. Whatever thing we're moving, if it's 12, we're going to subtract 12. If it was 7, we're going to subtract 7. If it was 9, we're going to subtract 9. But what if it was a negative 8? Let's keep the 6 here and move the negative 8 to the other side. Negative 8 plus 6 does equal negative 2. What can I do with negative 2 and negative 8 to get a 6? Well, this is a little bit trickier because we're involving negatives. So let's think about opposite operations. Let's add the 8 and add the 8 because it's a negative 8, and we write negative 2 plus 8. Ooh, does this give us 6? It does. So this is another member of our fact family that's going to work for this. It also works for variables. If I have 2x plus 5x equals 7x, that's a true statement. Let's keep our 2x and move the 5x to the other side. To do that, we would subtract, because we're going to do the opposite to move them, and we would get 2x equals 7x minus 5x. Does 2x equal 7x minus 5x? Yes. In fact, we could combine these like terms if we wanted and write this as 2x equals 2x. In fact, that's what we're going to do down here in this equation. So I got one more I want to try before we get to that equation. Let's keep our x and move the negative 4x to the other side. So remember, we talked about this. I'm making marks all over the paper. I don't want to do that. X is going to equal, we have a negative 4x. Let's add our 4x and add our 4x to get negative 3x plus 4x equals our x. And negative 3x plus 4x does equal x. So we're in good shape there. Okay, so here's the whole purpose of what we're doing. We are going to solve this equation, and I want to show you two ways to solve this. The first way is the way that I'm going to recommend that students do this. I'm going to recommend that you're going to move the 2x over to the 7x. So when we do this, we're going to do the opposite. We're going to subtract 2x on both sides, and we would get 30 equals 7x 7x minus 2x, and I don't have to write the 7x minus 2x, I can actually write the 5x. And now this is something that we can solve. We can divide by 5, and we get x equals 6. Okay, everything's going pretty well. We could also move the 7x. It doesn't really matter which variable you move. What's important is that we do the opposite to move it. So if I subtract 7x and subtract 7x, I'd get negative 5x plus 30. And then over here, it's just not nothing. 7x minus 7x is 0. The problem with this is I have to work with a negative variable. So you can always move your variables to work with a positive amount of them. And that's my suggestion to you guys, is when you work with them, move them so that you're going to get a positive amount. So from here, I'm going to, let's see, subtract 30, and I get negative 5x equals negative 30. Divide by negative 5, and get x equals 6. I get the same thing in the end, but I actually went through an extra step over here than I did on this left equation. Okay, I have these steps written on the board. The steps to solving any equation are to distribute, which we've done before, combine like terms, which we've done before, and then we have to move all variables to one side of the equal sign. This is our new step. Once we do this, we can solve using reverse order of operations. So let's put this to some practice. You can copy these down and try them on your own. Just copy them, pause the video, and see if you can solve them, and then you can hit play to see if you get the correct answers. In question number 1, my suggestion is to move the 3x to the other side of the equal sign. Subtracting the 3x and subtracting your 3x will give you a positive 7x, and it's going to be easier to work with. Don't forget that minus 14 is negative 14, so you have to bring the negative sign down. And when you divide by 7, you get x equals negative 2. You want to move all your variables to one side of the equal sign, and it doesn't matter. I could move the positive 2x to the left or the negative 2x to the right. I'm going to move the negative 2x because when I do this, I end up with a positive value for my variables, and everyone likes working with positive numbers. Solving this then, I'd get x equals 3. Okay, question number 3, line down the equal sign. This time it's going to be more convenient to move the 4x to the left. Doing so subtracts 4x and subtracts 4x, and I just get x plus 7 equals 21. Get rid of this pesky 7 by subtracting it, and we get x equals 14. And number 4, it's more convenient to move the negative 6x by adding 6x to both sides of the equal sign. And you're going to get 1 equals 3x plus 10. Subtract your 10 from both sides. Divide by 3. And you get x equals negative 3. I'm going to skip over 5 and 6, and I'd like to get to questions 7 and 8 because 7 and 8 involve more than just moving variables to one side of the equal sign or the other. You're actually going to have to combine some like terms first. You can't combine all like terms, you just have to combine some of them. So when we combine the negative 4x and the 2x, we'll get negative 2x plus 8 equals 3x plus 12. Move all your values of the variable to one side of the equal sign, so I'm going to move my negative 2x to the right by adding 2x. And we get 8 equals 5x plus 12. And then we solve using reverse order of operations. 5x equals negative 4, divide by 5, and I get x equals negative 4/5. Don't be scared if you get fractions or if you get negative or decimal values. All right, number 8, we can combine some like terms. We can combine the x and the 3x. When we do, we have 10 plus 6x equals negative 2 plus 4x. I'm going to move the 4x because moving the 4x will give me a positive value for the variable. So I get negative 2 equals 10 plus 2x. Subtract our 10 because I'm now solving by reverse order of operations. And I get x equals negative 6. So if you have any questions, you can message me in Canvas. But this is how we're going to solve equations with variables on both sides of the equal sign. The key is we have to do the opposite to move the value of the variable to the other side of the equal.